All right. Okay. Okay, for the second part, let's play a game. I'm gonna pick a random name, and that person will try to answer that question or guess. And if the answer is right, I'll give extra 2 more for assignment 2. Yeah, seriously. I'm marking it, right? I can do that. Okay, deal? Okay, all right. Huh? Okay, if it's wrong, it's okay. So no bonus mark. So each person get 1 chance. Actually, it's SRS, so you either get a chance or no. So the first one, Surgeon Leo. The person here? No? Oh, too bad. Okay. Next person. Zaglia? Who's this? Oh, you can't see. I'm sorry. Oh man, that name is now. Okay, that's you. Okay, so what's your answer? Okay, not this one. We've done this one, right? Okay, this one. Zero conditional mean, columns is independent, variance is sigma square I is identity, matrix. What's identity matrix? What's diagonal matrix? Diagonal matrix is where you have the diagonal to be some value, any value, and the off diagonals are all 0. So identity is a diagonal matrix where the diagonals are all 1. Okay, so basically you multiply that by sigma square, which is a constant, to turn that one value of constant into a matrix form, right? So all diagonals will have sigma square, sigma square, sigma square. Okay, so that's identity matrix times 10. So what's the answer? A, B, C, D, E. A. Okay, correct. A will be the best linear unbiased estimator. So you have zero conditional mean, linearly independent, and you have homoscedasticity as well, correct? So the answer is E. Okay, I should write that down somewhere. Okay. Okay. Zheng Liang, correct? Okay, so I'll write your name here. Okay. Got witnesses, right? Okay. I have to get full mark, then cannot 102 lah. Wow, confident, got full mark. Okay. We know that the model satisfies all assumptions of the classical linear model. Then beta hat OLS B will be. Oh, is that the same question? Okay. A, B, C, D. So who's next? Let's pick a random name. Okay. Answer is? Sure. Conditional on X will have N, where the mu is beta, and that as the variance. B. C. Okay, that's B. All right, good. All right, so 2 people already. Okay, next. So we have data on infant mortality, GDP per capita, and expenditure as a percentage of GDP per capita. So we have those things here. You've seen all that. Based on information reported above, we can say that, okay, more than half in the sample having mortality smaller than or equal to sample mean, less than half smaller than sample mean, more than half smaller than sample median, less than half smaller or equal to sample median, or none of the above. All right. Okay, so who's turn? Ah, who's that? Ah, there you go. Okay. King Hui. Okay. Yes. What's your answer? Why did you get? You want to change name, is it? Yes. C? C. More than half of the country sample have infant mortality smaller than the sample median. Okay. Yes. So it's C. Because median by definition is a middle, right? So 50% or half is more than that, and 50% is less than that. So mean, not necessarily the middle. It doesn't divide it 50-50. Okay? Right. Unless you have a perfectly symmetrical distribution, then your median, mean, and mode are equal to each other. So that's all right. Oh, is it wrong? Oh. Oh, so the answer is wrong. See. Sorry. More than half the country's sample have infant mortality smaller than the sample median. Ah, shoot. Yeah. What is it wrong? C is wrong. I'm sorry. Why is it wrong? Because it's more than half. Oh man. It's half. It's exactly half. Not more than half. Okay. So okay, let's look at it again. So more than half. So median should be exactly half above and exactly half below. Right? Okay. So B less than half of the same. Look at this carefully. 25. Ah, okay. This is quite challenging actually. Okay, so less than half. Okay, C and D are wrong because it should be exactly half. More exactly half, less. So it's between A and B. So how do we know? Based on the skewness. Correct. Right? So how do we know the skewness? So we look at mean and median. So here we have the mean higher than the median. Therefore, is right or left skewed? Is positively skewed, right? Because the mean is being pulled up, right? So it looks like that. And the mean is somewhere here, and the median is here. Okay? So from this median, we know that this is 50% and this is 50%. Right? Since this is the mean, so we know that less than the mean is more than 50%, and more than the mean is less than 50%. Okay, so the answer is A. Sorry. It's okay, you may get picked again. Because SRS, right? So my mistake. Okay, so answer is A. So that's how. Quite tricky, yeah? All right. You got it? Okay. The explanation clear enough? Okay. Yeah, next one. Maybe you need to come up again. So sample correction. If we run a regression on infant mortality on a constant, only the OLS estimate of the constant will be. Oh, this is easy, right? Oh man. Wow, just now was so difficult. Now this is so easy. Just your luck, huh? Okay, good. Okay. Hamza. Are you here? Yes, you are. Okay. So what's your answer? Answer is B. B, yes? 25.8, which is the mean. So you on the constant only, it should be the mean of info mortality, which is 25.5. Okay. Good. All right. Okay, thank you. So next one. Relationship. Okay. Oh, there's a lot. These statements have been made. Relationship between info mortality and GDP is non-linear. Log is more suitable than level. Info mortality and GDP has negative relationship. R square of log will be higher than R square of level. Which of these four can be inferred from the information above? Okay, whose turn is this? Who's this? Zayuan? Sure. Zayuan? Am I pronouncing it right? Not here? Oh, see? Okay. Rawan. Oh, there you are. Oh, the back row. Okay. What's your answer? A, B, C, D, E. Sample correlation, is negative 0.61. Log is 0.086. Scatter plot are provided. Oh, what's scatter plot? Scatter plot. Do you see the scatter plot? No, right? I assume it's there. Imagine. Okay. What? Any guess? No? Oh, no. Sure? You want to guess? You have 20% chance of getting it right. So just choose something, right? I missed it just now. Sorry? C? C for cat? Meow meow. Okay. So C, 2, 3, and 1, 2, and 3 is non-linear. That's probably from the scatter plot, isn't it? So you can't see. Did anyone check because this is from your, oh, it's in front. Oh, there. Thank you. Okay, so info mortality and GDP. Okay, yeah, that looks non-linear. Right, okay. So that's okay. Log model suitable than level. Okay. Why is that true? Because non-linear, right? It looks like an exponential shape. So there's an exponential relationship. So that in functional form, that is manifested in a log model. Okay, that makes sense. So 3 have a negative relationship. That's true also. It's downward sloping. It's negative. 4, the R square of log will be higher than R square of level. So that one we can't tell, okay? Okay. So the answer should be answer is D. Can we tell if the R square is log will be higher than R square level? Yeah, actually we can. Can you tell? How can we tell? Because it's non-linear, right? So you can't calculate it, but you can tell because if it's a level, then the best fit line is a straight line like that. Okay, which wouldn't fit so well. And it doesn't fit so well, the R square will be low, right? So a log model will look more like that. Fits better, R square should be higher as well. Okay, all right. So you can't calculate the actual value, but you can take a guess. You can see from that. So this. Oh, Rawan, sorry. Okay. Well, 20%, right? 1 out of 5. Okay. So D. All right. Okay, next we run a regression. The coefficient of log GDPBC tells us that how. Oh, this is interpretation. So that's okay. A, C, D, and E, they all have the ceteris paribus part, right? In countries that spend same proportion of GDP on health, they're referring to the other variable. So holding that variable constant. Basically, that means that. B doesn't have that. So that should be counted out already. Wait, what am I doing? Okay, let's skip this one. So next question we run. Okay, so A, B, C, D, E. So which one? It's a log model, right? So it should be percentage to percentage. All right. So anything that's not that is wrong. So D is wrong because it's 73 instead of 0.73. E is wrong because it's children instead of percentage. Okay. Same with C as well. This is not 0.3 and this should not be. That's all children. So it's A. Percent to percent, 0.73. Okay. Equation 2, the coefficient of expenditure on health tells us that. Okay, before I do anything. Jadi, how do you know? Oh, you know. Right here? No? Okay. Next one. Eugene? Eugene. Okay. Here we go. Okay. Which one? B? B bola? Sorry, ball? Bangladesh? Yes or no? Wow, the group assignment discussion. No? You have to divide already. People. So in the country with the same GDP per capita, 1 percentage point increase in the share of health expenditure in GDP decreases the predicted infant mortality by 10%. Agree? Yes? Okay. So, yeah, that's good. So percentage point, right, instead of percentage, because it's not log model, it's level, but health expenditure in terms of percentage of GDP. So that's good. And decreases because it's negative. And you multiply by 100, right? 0.1 times 100, you get 10. Okay. That should be all right. Let's just check. Okay. Right, correct. Oh, shoot. Okay. Eugene, right? Okay, Eugene. Okay, anyone see the answer just now? No? Okay, good. Okay, equation 2. The value of R square shows that 0.79. Okay. So those terms. You? Okay, she's here. All right. Yi Chi, is it? Pronouncing right? Okay. I have to learn the spelling. Okay. A, B, C, D. C. Okay, C, 79% of the variation of log in the example is explained by variation in the log GDP and HGC. Is that correct? C? Okay. Why is it C and not D? Okay. This is interesting. It should be correct. So it's C because it's log, right? But now, I want to relate to when you interpret. So in terms of R square, yes. So you should use the log if it's log model. So you should log and put the log. But when you interpret, it's not log. It's percentage. Like this one, right? All right. So infant mortality by this one. Yeah. So you don't say log infant mortality by 0.73%. is infant mortality itself. Okay, just in case that it's confusing. So don't confuse that. So when you interpret this, the log is not there. It's converted into percentage. But for R square, yes, the log stays. Right? So it's not B, it's C. All right. So E, G, correct? That's it? All right. Okay. Wow. Okay. 47, page 47, almost there. Okay. Question 4, coefficient will be C 4.14 here. This is quite easy. Okay. Yang Hun. Anyong. That's all. Oh, him. No, not here. Oh, different time zone. Probably he come from. Okay. Sorry, Yang Hun. Yang Han. Hey, you again. Okay, no. Only one at a time. No. No. I suggest not only one. I did. Okay. Wow, this is a long name. Okay. Who's here? Not here? Isakya? You're not here. Random again. Ikan. To you? Okay. Okay. Easy question, right? Which one? E. On its own cannot be interpreted because GDPPC square is also in the regression. Agree? Yes, that's right. So it's E, right? Because you have it there, so you have to interpret differently. So what should the interpretation be? It should be this. Okay? So dy dx. So you should combine both of those coefficients, and then that's the marginal change. Okay. So be careful. Right? You just focus on that, then you didn't notice that you have GDPPC square over there. Okay. Ikan. All right. Okay. Congrats. Okay, one already, right? No, only one. Okay. So it's not random. It's random, condition on me. Okay, it's SRS conditional. So if we estimate the model without GDPPC square, the R square, the regression without, okay, will be, okay. Which one? So who's this? You. Okay. You guys are sharing mark, is it? Okay. B, is it? B will not be larger than the R square equation 4 under any circumstances. Why is that? Otherwise, only give one more. No, I'm kidding. So B, why is it B? Why? What if you change it to adjusted R square? Do you get the same answer? No, right? Because R square, no matter what you add, reasonable or not, or nonsensical, it will still increase. Adjusted R square, no. It can decrease even if you add nonsensical variables. Right? So B should be okay. Should be correct. Okay, will not be larger than R square under any circumstances. What's your name, is that? Jingyi. Okay. Assuming that all assumptions apply, the T statistics has a distribution. Okay. It's quite interesting. Okay. Okay, now, one time. Huilin. There you are. Okay. Linear, quadratic, linear, quadratic, quadratic. This is a good question. Ah. Okay. You answer first, then I explain. Yes? C, D, donut. Oh man. Okay. D, right. D donut. T with degrees of freedom 1 to 9, distribution if the relationship between CO2 and GBC is quadratic. Okay. You agree? Not sure. So beta 2 refers to which coefficient? This one, right? Okay. Right. So what's the consideration here? So we're talking about, actually they're asking you about, oh, I hope I'm right. They're talking about, okay, okay. They're asking if, what is the null hypothesis? So what is the distribution under the null hypothesis? That's what you're asking. Yeah? So null hypothesis will be beta 2 equals to 0, yes? 0, right? Okay, if beta 2 equals to 0, then do we have quadratic or linear? Quadratic or linear? Linear, right? So we won't have this. So 129 is correct. So 132 minus 3, so 129. So between these two, quadratic or linear? It should be linear under the null hypothesis. The answer is C lah. Yeah. Okay, let me check. The answer is C. Okay. Sorry, good try. Okay. This is tough. This is a difficult question. Right? So because when you, which is why if you write the T statistics, it will say under null hypothesis, right? Because it follows null hypothesis. So null hypothesis is equal to 0. So when beta 2 equals to 0, you don't have this, so you only have the linear. So when this is linear. Okay? In other words, under null hypothesis, under H naught. Okay, so the answer is C. Okay? Right. This is a tricky question. It's good. Right. Is that clear? Okay. Assuming all assumptions are apply, the statement of CO2 emission of a country will eventually decline when that country becomes sufficiently rich, can be investigated by testing. Okay. Do we want? Oh, next to each other. Oh, there's an Ong row. Okay. Lucky row. Okay. What do you think? A, B, C, D. This is a good question too. B, ball. Okay. B. So, you want to explain a bit? You were thinking just now? So what is it actually asking? It's asking if the quadratic, the turning point is maximum or minimum, right? So if eventually declines, meaning it started upward sloping and then it becomes downward sloping. So it's a maximum turning point, correct? Okay. So maximum turning point, you would have the linear to be positive and the quadratic to be negative. So we are testing beta 2 to be 0 and beta 2 to be less than 0. Okay, so that should be correct. Just check. Okay. Great. All right. Jai? Oh, that's you? Okay. I should check if it's a real name, isn't it? Okay. Okay, next one. From result equation 4, you can infer that. Okay. E, the percent CO2 emission per person is at its maximum when GDP per capita is that. So it's asking for the turning point. Yes? Okay. So that's a turning point. Is that correct? What's the formula for turning point? Is negative beta 1 over 2 beta 2, correct? Yeah? Okay, so beta 1 is the linear coefficient and beta 2 is the quadratic coefficient. So in this case, yes, so it should be this. All right. Because beta 2 is negative, so the negative cancels out the negative. All right. This should be it. Just check. Okay. All right. Good. Okay. Next. Okay. If GDP per capita was measured in dollars instead of thousands of dollars, all right. This is a scaling question. Azrin, are you here? You? Okay. You look shocked. Are you happy or unhappy? Conflicted. Okay. Ah, okay. So which one? A. A. The estimated coefficient of GDP square will be 4.14 times 1,000 equals to 4.14. Okay, and our square would not change. Okay. A. You agree? I don't think so. Which one do you think? The rest of you? C? Why C? Why C? Because it's square, right? So it's GDPBC square, so you have to square the 1,000 also. So you have 1,000 there, and 1,000 square will be 1 million, correct? So that's 1 million. So that's the only one with 1 million, isn't it? Right. Yeah, it should be C. Right. Okay. Sorry, Azrin? Okay. So C. All right. Nice. So you have a lot of questions. All right. Okay. Okay, you've read that. So based on the assumptions reported above, we can see that population mean, sample, make more, okay. Already, right? Yes. Which Eugene? Right? Already, right? Okay. Wow. Have I called his name? No, right? No, right? Okay. Oh, yeah, not yet. Okay. A, B, C, D. One out of five. Any idea? A, B, C, D, C? C is it? Cow? Moo? Okay. 9 companies in the sample made more than $9.2 million. Okay. That's the median 9.2. 9 companies. That's specific. So let's look at one. A, the population mean of profits is 11.6. The population mean, this is a sample mean. Can we say the population will be 11.6 also? No, we can't say that. It could be true. We can't really say that. So 9 companies in sample made more than 11.6. Can we see that? This is a skewness thing again, isn't it? Right. So what skewness is this? Same skewness, right? It's right skew. Like that. So median is here, 9.2. Mean is here, 11.6. Okay. So more than half would make less than half would make more than 11.6. So is 9 correct? 9 is less than half. So it's possible. You see here? Okay. 9 companies sample made more than 9.2 million. 6 million. Okay. So that will be here. C. You think C is correct? 9 companies in sample made more than 9.2 million. Okay. Yeah. Distribution of profits in the sample is skewed to the right, so we recommend log profits to be used. Okay. That's probably true also. Now the above. Okay, so since median is 9.2, so at least 9 will make more than that, correct? At least 9, right? Not exactly 9, well, 19, right? So I oh, right. So exactly 1, right? Oh, okay. So 9 above, 9 below, and 1 in the middle. So you get 19. Okay, because median is one value of somebody. Okay, the answer is C. Right? So it's 2 possible answers. So 9 is, if you have to choose 1, choose 9. So E is acceptable also. Right? Okay. So that's the official answer. So C is correct. Why could C be wrong? Because the one above that's right. That's possible also, right? So 9.2 could be, you can have like 3 9.2. 9.2 median, and above that is also 9.2, and below that also 9.2. Right? So you can't say for sure. That's possible also. So C is not entirely accurate. Not always. Can be true, of course, but there are cases that it is not true. All right. Okay. So it could be C or E. Okay. So C is correct. Okay. So we run regression of profits on a constant. Only the this is jackpot. Okay. So who's next? Already, right? Yeah. You were. Ah. He's not here. It's not here. Oh, you're here. Oh, there you are. Oh, okay. So far up there. I can see you. Okay. Okay. He's here. Yes. What's your answer? A? Straya? A? Okay. What? Okay. So there should be a constant. should be the mean. So 11.6. Okay. Okay, there you go. Oh, easy. All right, so next. So profit on owner and manager from the SPC equation, we can infer that. Okay, this is quite easy also. Okay. Darian? Okay, there you are. Oh, I have to read the question first. Yeah. Two variables, owner and manager. If a firm is managed by its owner, the value of owner for that firm is 1. If the manager is 0, the firm is managed by the manager is not the owner, the value of owner is 0 and manager is 1. Okay. Right. So what's the interpretation? Where are you? B? Ball? Okay. The average of the profits of the 7 owner managed firms in the sample is $10.4 million. Okay, so this one, right? So B. Agree? B? So, how many groups do we have in this regression, this data? 2 groups, right? You're the owner who's also a manager, or you're a manager who's not the owner. Are they a manager is the owner? So you put both here because you excluded the intercept. So if you add the intercept, then you can't run this, right? If you drop one, let's say manager, you drop or owner, then you have put intercept, then the beta would be the difference between owner and manager, right? In this case, it's not the difference, it's the mean itself. Okay. Yeah, so that should be good. All right. Oh, living room. What class? Oh, I miss out on bonus mark. Okay. Okay. So profits again. So if we form a 19 by 2 matrix X, the first column goes very binary, then which one is not true? Okay. Johannes? Are you here? Yeah. Wow. When I pick people's name, they seem unhappy. No? Like, oh man. See, these people are waiting for their names to be called. Keep praying, praying, praying. I think so. I may have excluded on purpose. Yes. D, E. E, so x prime, x is 7, 0, 0, 12. Okay. Let's see. Oh, so it's D, identity matrix. So why is that not true? Okay, let's see. X prime is identity matrix. Okay, well, you know what identity matrix is, right? So that's just like that. I have 1, 1, 1, 1, 1. Everything else is 0, 0, 0. 2 by 2. That's correct. Symmetric. That's correct also. Invertible. Yes. Okay. Identity. Oh yeah. What 1001? Yeah, so it's not identity, right? Yeah, so it's not one, so everything else is correct. They said it's not identity. Identity is basically is just one. It's meaningless. So it's not there. So it has some information there. So it's not identity. Okay. Sorry, Johannes. But now you remember this, you never forget. So you get 2 extra marks in the exam. Not by me, but if you answer correctly. Okay. All right. So we form matrix Z by adding the third column to X. All 90 elements of this column are 1. Which of the following is correct? Okay. This is quite easy also. Very long question, isn't it? Wow, you guys really want it, huh? Kendrick? Are you here? Yes. There you go. Fix your glasses first. Okay. Don't look at me, look at the question. Oh, you didn't bring your question. Okay. Okay. So which one? Matrix Z, adding third column. E is Z. C. C. Columns of Z are linearly independent because the first column plus the second column minus the column is 0. Oh. Okay. So A is linearly independent because no column is a scalar multiple of another column. Are orthogonal to each other because transpose of each column times another column is 0. Okay. 1 plus 2 plus 3, 0. Vectors are equal length because sum of squares elements are equal. Oh, a lot of crazy stuff in there. So let's see. So linear because the first column plus the second column minus the column is 0. Okay, all right, C. All right. Okay. This is not always the case, though. It is in this case. Why? Because you have a dummy variable, right? So the first one is, well, the third column is always 1. That's the constant, basically. So the independent because the first column is 1 plus the second minus the third is 0. Yeah. So in this case, yes, it's always true. Not always the case because you have the constant and 2 dummy variables only. If you have a non-dummy, then it's not true. Okay. So food consumption. Okay, we have about, I think, 10 more questions. Okay. The estimated coefficient of log income shows that, this is quite easy, isn't it? Interpretation. C. Gini. Gini. Sini. Sini. There you are. This is almost full house, isn't it? So far, only what? 1. The name that I called. It's not here. Right. Not bad. Yes. Okay. So which one? C. Okay. So C, 1% increase in weekly household income increases the predicted weekly food consumption by 0.57%. So that's percent. That's correct because we have log model, correct? Okay. So $1, that should not be correct. 57 cents, not correct also. This one is divided by 100. You don't need that because it's log. And this is 1% and 57%. That's multiplied by 100. So you don't need that either. Okay, so it should be C. All right. Okay, there you go. C. Okay. Estimated coefficient of NH shows that. Okay, this interpretation also. Killing. Who's killing? Oh, you. Oh, now you read the question, huh? You're prepared before. I should have a time limit, isn't it? Only 5 seconds. You don't prepare, that's it, gone. Next year, I'll do it. B. B. Adding 1% to the household increases the predicted weekly food consumption by 8%, keeping household income constant. Okay. So this is a log level interpretation. So you have to, so adding 1% and you have to multiply the beta by 100. Right? Okay. So it should be B. 1% and 8% because 0.08 multiplied by 100 because it's a log level. Okay. When does this become approximately inaccurate? When coefficient of beta bigger than 0.1. Then what is the calculation? It becomes 100 times e power to beta hat minus 1. Okay, this is 0.08, so that's still okay. The approximation is still all right. If it's more than 0.1, then yes. It's exactly 0.1. That's hard to say, isn't it? If it's exactly 0.1, I think the approximation is still okay. Yeah, so you don't have to do this. Would they do that in the exam? That would be cruel. Yeah. If that happens, you call me. Yeah. So I'll be around during your exam. So if that happens, you call me because that would be quite confusing. It's not fair. They should give both answer correct. Of course, it's more than 0.1, strictly speaking, but it's too same as if what if the significant the p-value is 0.05? It's exactly 0.05. What do you do? Don't call me, I'll tell you now. Is it significant or not? 0.05. If it's 0.05, it's not significant. Significant only if it's less than 0.05. If it's exactly 0.05, it's not significant. Okay, that's quite clear because it's probability. It has to be less than that, just in case that comes out. But if you're still not sure, you can call me. Okay, I'll be around. You tell one of the uncle aunties there, tell them, please call my lecturer. Then they'll call me. Okay. Don't ask them. They have no idea what you're doing. They are mostly retired teachers from Seremban and Ipoh. Seriously. Yeah. Very grumpy all the time. Okay. All right. What? Okay. The log is the estimated intercept cannot be interpreted. Show the predicted value. Show the average of. Okay. Video lihat. There you go. Okay. You didn't bring your question. I should disqualify you for not bringing questions. Yeah, I'll take notes. Next year I'll change the rule. Okay. Cannot be interpreted. Shows predicted value of food for household average income, average size. A cannot be interpreted because there are no households with NH 0. A, that's my name. NH. I'm not 0. So what does that mean? NH is what? Number of household, right? People in the household. So can you have that 0? No, you can't, right? Well, you can interpret, but the message will be meaningless because you can't have household 0. You know, that's not a household. It's a house, but it's not a home. It's empty, right? It's house empty. What am I saying? It doesn't make sense. Okay, so answer is A. Okay, so pay attention to this kind of stuff. So even in the non-MCQ, they will ask things like this. When they also interpret the intercept, so you have to make sure. We've done this in tutorial a lot of times, right? So either you interpret it when this and this and this is 0, this is the value. You say that, and then answer is it sensible? It's not if income cannot be negative, or you either refer to the value of the context of the variable itself, where like a household cannot be 0, for example. Age cannot be 0 because, well, that's a baby. You can't have an income in when your age is 0. So either in the context of the variable using common sense, or you can use the sample itself, the data. You can use the median or the mean or the minimum or the maximum of the your sample itself, right? For example, if they say like income, can this, if when income is 0, this is the value of y variable, whatever it is. So you can say, oh, it makes sense, income can be 0, but there is no 0 income in your sample, right? So it's not relevant to that. So you can see it in those two, either in the context of the variable, use common sense, or look at the data that's given to you and comment based on that. That's acceptable too. Okay, also remember that. All right. Okay, the value of R square shows that R square. Silly. 3 here? Yes? Okay. A, 93% of the variation of logarithm of weekly food consumption. The example explain the variation of logarithm income. Yes? Agree? A? Seems okay. E, right? Okay. The key thing that can confuse you there is there's a logarithm there, because it's a log model, so it should be logarithm. So this one, this is wrong, 7. It's wrong, 7. Okay. 93 is correct. But this one has no log. Okay, so it's wrong. Okay. E, this model predicts the weekly food consumption of 90% of household the sample perfectly. Okay, that's not what R squared is, but there is a measure for that. If you do forecasting, there's something called percentage correctly predicted. Okay, so you can have that. We didn't do that, but if you do forecasting data 3420, then you have something like that. So that would be the interpretation. You 90% of the household in the sample, you perfectly predict. But that's not what R squared is. So that's something else. Okay, all right. Just FYI. Oops. Okay. Okay, almost there. We're past 5 o'clock now. So okay? So go? Okay. Right. Okay. And my hypothesis that given household income as per the value logarithm for consumption does not depend on the number of people living in the household. This statistic has 2. Okay. All right. Maisa? Oh, that's you, right? Okay. Yes? Hey, your name is not my name. Is that your name or your father's name? Your father's name. Hey. Okay. All right. So which one? Under the null hypothesis. Ah, which one? C? Huh? C or D? Or E? Or A or B? Ah, either or one of those five. E. Ah, elephant. Elephant. T34. So degrees of freedom, 34. So basically you have to choose degrees of freedom here. So 1 is not 36, not 35, 34. So n is 37, so n minus k minus 1, k is 2, and 1 for the intercept. So 37 minus 3 is 34. Yes? Okay. Yes. Are you confident or not? Yes. Okay. So, it's E. There you go. All right. All right. Okay. Good. Okay. I think we have about 4 more questions. Okay. Charis? Caris? Caris? Are you here? Ah, there you are. Okay. Is it Caris or Charis? I think I asked this in week 1. I forgot. Caris? Ah, yes. Okay. D. D. Donkey. D. Okay. So which one of the following option best describes what this scatter plot suggests about the bivariate relationship? Bivariate, two variables, as opposed to univariate, or multivariate. Price and number of bedrooms. It's this one. So you see it's linear and increasing. Okay. Price and area. Linear and increasing. Okay. And price and distance to the nearest train station. Quadratic. Okay. Do you agree? Does that make sense? Yeah? Okay. I think so too. So 1, 2, 3, increasing and quadratic. Okay. Right? All right. Why would the distance to the train station be a quadratic relationship? Why is linear is obvious, right? The closer you are to MRT, LRT is more convenient. So, that's what. Noisy, right? Well, assuming this is even now, right? The LRT now is quite noisy, right? The MRT, which is why you have in the Damansara area there. They have that little, not little, it's big, the huge shield around the track. Why? Because there's rich people there. The poor places, they don't put that. No, it's true. Well, from my observation, I don't have the data. But over there, because they will complain. Huh? Sorry? Oh no, I don't stay there. No, I don't. Oh, good guess. No, I don't stay there. But it's true, isn't it? So they put there because a lot of it's an affluent areas, people would complain. It's also the shopping mall and all that. So they want to reduce the um, noise pollution. But we have a lot of places with that also, in the kampong and all that. They don't care. They don't put that up. So yeah, that's a bit sad. Well, new government now, maybe it's going to be different. Okay. So yeah, so convenience and noise pollution, right? Okay. So that could be the case where we have quadratic. All right. where I live, is it? Where I live, there's no tree. See, very poor area. I think they're building one now, bro. The third phase of LRT. All right. So price-based area train and train square. So we have the estimated regression. Notation equation 6 is incorrect. Okay. Oh, it's correct. So which one? Okay, this person's not here. Yes, I called his name just now. Not here, right? Yeah. Irene. Irene? This is really random then. Oh, there you are. Ah, okay, sorry. So small, cannot see. Okay. Irene is here. She's not small, it's far. Sorry, not small, far. Ah, okay. E is correct. Yeah? That's your answer? Ah. So the first one is incorrect. There should not be a hat on price. That's not correct, right? There should be a hat on price because it's estimated. Okay, that's wrong. Okay. It's incorrect. There should be plus U at the end. No, because when you estimate it, the estimated value of U is 0, right? Okay, so you don't have U. There is, but it's 0. There should be U hat. Also not correct. That's 0 also. It's incorrect. On the left-hand side, there should be expected value of price. Okay, how about D? Okay, D is wrong because train square is not there. That's true. But if there is train square, would that be correct? Not correct also? If they have train square and you put that instead of price hat, would that be correct? Why not? So if this is wrong because there's no train square, but if there is train square, then you can write that too, right? Which is why expected value of U given X is 0. See? That's why you don't have the error at the end. That's why it's 0 because 0 conditional mean. So if you have train square, that would be correct. Yeah, so in this case, it's not because you have to have train square. So it's E, right? There's no problem. That's correct. Okay. I read. All right. Okay. The last few questions here. Test hypothesis: a given area, distance, the nearest institution, number of bearings against the distance that is positive. The null alternative are. Let's talk about the number of bedrooms. So this is easy. Oh, this is the third time, right? Actually, that's not true. If you select this, then it's really random. You know the shuffling in your Spotify and all that? It's actually not entirely random. Some they choose the nearly added first. They play more the songs that you add recently. So that's better, isn't it? So they try to not be, it's actually not fully random. I just read this yesterday. Yeah, so if it's fully random, then is this is bias and this is bias. You did something. No, I'm just kidding. Okay, but yeah. Shuma, she here? Not here. Oh, okay. This is second person not here. Okay, same group. Oh, Philip, see here? I've not seen him the whole semester actually. He was here last semester. I should tell you that. Okay. Finally. All the noisy ones. Okay. Jiamin. So which one? It's you, right? D. Beta 1 equals to 0 and beta 1 is more than 0. Against the alternative that it is, and the slope is positive. Okay. So there's a direction, so it should be there. Yes. Okay. Let's do. Why is C wrong? Because there's a hat. When you test a hypothesis, you refer to the population parameter, not the sample coefficient. Okay. All right. So it should be D. Okay. This is second last. Yes? Sorry? Wow. Is your name, right? Okay, I write your official name. See, I remember her because one time she came to my room, my office. And then asking about assignments. And then I said, can or not? And then she said, can also must can. So I asked her to write that on my board. So if you saw that, that's from her. Can also must can. That's the spirit. Okay. Can or not? Can also must can. That's right. Okay. All right. Okay. Good. Okay, let T5 be a variable with 5 degrees of freedom and T115, 150 degrees of freedom. So probability, okay, that's quite a long question then. Okay, can we reject or cannot reject? Okay. Wow. Is that a third time? Already, right? Ah. What's the matter? Not here? Not here. You know for sure. Okay, okay. Oh, this last few very dramatic. Okay, Z1? How are you? Have I called you? No. All right. Wow, so all three have been called. Okay. Bias are this random name picker. Yeah. I'm good. Yes. Okay. Answer is ball. Correct, ball. Bangladesh. AB. Reject the null because T calculated 63.7. 1.66. Okay. Ah. Okay. Okay. So 63 is what? They confuse you with a lot of things actually. Okay. So what's important here really? 5% level is important. And they give you all these degrees of freedom so that you can choose which is the correct degrees of freedom. Basically, you don't need to know all of them. So this one, 63.7 is taken from here. So 63.7 divided by 35.5, right? So you get 1.8. That's their statistics. So compare that to the critical value. Critical value is for 5%. So that's 5% there, right? And so other than 5%, so these two are wrong. So between these two, so you have degrees of freedom 115 and degrees of freedom 5. So obviously it's 115. Where do you get 115? What's the n? N is 120. Okay, 120 minus k, 1, 2, 3, 4 minus 1, so 5. So 115 is degrees of freedom. Okay. You follow? Okay, so it should be 116. So that's what they're asking. 5%, you know that is 5%, you know degrees of freedom, and you know how to calculate test statistics. So that's what they're testing. Okay, all right. So B. 0. Okay, I think this is the last one. All right. From the results of the equation, since you can infer that, okay, this is addition. Oh, already. Okay. I haven't picked this name. Chui? Where are you? Anybody wants to change the name to Chui? Not here? Oh, okay, not here. Oh, this last few questions very dramatic, huh? Darini? Okay. Oh, right in the middle, the last one. Okay. Answer is D. E. Elephant. Keeping the number of bedrooms and area constant, predicted price is maximized when house is 1161, 8.8. Okay, so that's a turning point, correct? Okay. Okay, there you go. Yay. All right, so that's the last one. The end. Okay. So good luck for your exam. Okay. I think, as I've said before, you work very hard. See, even today, it's quite a full house. So thanks very much for making an effort for yourself, not for me. Assignment 2, I'm still marking. So we are targeting to release the marks on the 4th of June. So that's the target. I have to calculate all the peer review and all that. Okay. Any last words? Yeah. So can I also mask it? Okay. So we'll be here for you to help with anything. So please look for us, okay? Okay, all the best, good luck, and take care, eat well, sleep well, and take care. Don't fall sick, don't get into an accident or anything like that. Okay, I'll see you around. Good luck, guys. Okay, bye-bye.
Sir, we looked at MCQs and all that. Why not we discuss the last section, the main section,
Which is it?
the section 5?
Oh, I think we discussed that a little bit, right? The important ones. So MCQ, it covers a lot more things, especially the cross section stuff.
Because right for time series, we said there could be 2 questions, right? Usually that's the structure, but then our time series we don't have forecasting and all that anymore.
Yeah, you do.
So probably like
So you have less to study.
less to study, more repetitive. Okay, and
We have the notes for the section 2, right? Does it mean we are only focused to study the one?
Section 2. Yes.
Does it mean we should focus on those topics?
Those covers most topics.
Those cover more than
Not really. No, it doesn't work like that. Yeah, they don't show that as like this is the spot questions, but yeah, everything that you should know. Mostly the test, isn't it? The HSK test and the BG test and all that. So in my those like actually not easy, but if you know, then you can do it quite straightforward.
this is the thing you showed us on the slide.
Yeah, the second one. So this is the first one. So the second time. Yeah. But there's no those are not spot questions. Yeah. You don't do it like that. Unfortunately. I think because they think that's where most problems are. The